Not you, Becca.
Are you guys ready? Okay. So extreme values of functions, be familiar with what they mean. I should be able to give you part of a definition, say for example on page 187, the definition of absolute extreme values. It says let f be a function with domain D, then f of c is the A absolute maximum value on D if and only if f of x is less than or equal to f of c for all x and D. So an example of a quiz problem could be, I give you everything I just said except where it says in bold and highlighted absolute maximum value. So you know that we're talking about absolute extreme values, so looking at that you should be able to say, well, I'm probably going to fill in either absolute max or absolute min. And since for the first part A, f of c is greater than or equal to f of x, for all x and D, that first blank would be absolute maximum value. And for part B, the blank would be absolute minimum value. I think that's fairly straightforward. I'm not asking you to memorize the whole definition, but I think I should be able to give you the majority of it, and then the blank you'd be able to write in the piece that's missing. Theorem 1 on 188. So the extreme value theorem, if it reads, if f is continuous on a closed interval, a to b, then f has both a blank and a blank on the interval. We're on page 188. Theorem 1. Page 189, the title of the definition is local extreme values. So something like a quiz question, let C be an interior point of the domain of the function f, then f of c is a blank at C if and only if blah blah blah.
So you're just going to ask us definitions?
No. And these will be fairly quick because they're not actual problems that you're solving. You'll definitely have problems to solve, of course. Theorem 2, local extreme values. If a function f has a local maximum value or a local minimum value at an interior point C of its domain, and f prime exists at C, then f prime of C equals blank. Knowing that, okay, that'd be a horizontal tangent line, so its derivative should be 0. Critical point definition, page 190. A point in the interior of the domain of a function at which f prime equals 0 or blank is a critical point of f. So knowing that the two criteria, one being f prime equals 0, the other one being f when f prime does not exist. That's in the notes. So again, you don't have to memorize these. I hate to say don't memorize them by heart, because you should definitely look into them and try to soak in them. If you understand them, then I think you'll be able to fill in the missing part when I give you the definition or theorem, except for one blank. So problems that you will see are maybe ones like they're on the homework, except you're not going to be dealing with any sort of arc trig functions. There'll be none of those. So looking at something like on 193, that could very well give you something graphically. I think these are pretty straightforward, but if you guys have any questions about 1 through 4, please ask away. 5 through 10, again, graphically. Identify each x value which any absolute extreme value occurs. Explain how your answer is consistent with the extreme value theorem. Yes.
I had this question before on page 194.
Yes.
On number 8, would that point in the center be both the highest and lowest value?
That is a good question, and there is no max or no min. Because you can't, you know that there are values greater than at when x equals b, but there's no way to write them. Because how could you describe a value that, for example, is, say, when x equals a, let's say that whole is, say, 5. How can you describe a value that's just less than 5? There's no way to really write it. It's a very good question, and I encourage you guys that are following along to look at 8 and see what she's talking about, what she's referring to. This is page 194. There's no max, no min. And the extreme value theorem doesn't apply since the function isn't continuous or defined on a closed interval. Yeah.
Can't, like, she was saying the center point could possibly be the maximum min, and we said it wasn't. But isn't it also not on the max or the min because it's not specifically on that curve? Like, it's not a max or a min of that curve?
No, if that point, say, were, let's say, way above,
Yeah. Sorry.
if that point, say, were way above the rest of the graph, that would be absolute max. It's clearly defined what that point is.
Okay.
That's a good question. Yes.
Okay. And so for 10, would the maximum would be b?
The maximum would be at x equals a.
Even though
So that's there you go. So Kate, if you look at number 10, that's exactly what we're talking about. See how that point, that's an actual point, is above the rest of the function. So that is the maximum value because that's a clearly.
continuous, it's still because it's part of the function.
Yeah. So there's a maximum value, yes.
That does not apply.
But the theorem doesn't apply, and why does it not apply?
Because it's not exactly.
Very good. Exactly.
It's not continuous, it's not differentiable either.
Right. Yes, you may. You would just fill in a blank. Okay. 11 through 18. Use analytic methods to find the extreme values of the function on the interval and where they occur. So these are in the notes. If you missed any certain days, check out the flip charts that tells you exactly the steps you need to take to find extreme values. Yes.
Can you just do number 14 really quickly?
Yep.
14.
So in 14. Fourteen says we have k of x is equal to e to the power of negative x squared. And they're talking about the interval all reals for x negative infinity to infinity. Okay, so extreme values, again, let's go over those. 1, where f prime does not exist. 2, where f prime equals 0. And 3, check the endpoints.
So how can we extend?
So if there are no endpoints, you need to be familiar with the end behavior. Okay? For example, let's go with something very simple that you know. Say the graph of a parabola. A parabola will have, that's concave up, will have no absolute max because the end behavior is going to infinity as x approaches plus or minus. Okay? If they say like an interval like this, for example. Now, if it's a closed interval, you know, definitely checking the endpoints. Okay? Parabola concave down, for example, absolute max exists, but absolute min does not exist for the entire domain. Yes.
So I know you said no trig functions. Should we expect to ease in natural logs?
I said no inverse trig functions.
Inverse
I don't
trig,
expect
okay.
you to know arc sine, arc tangent, and all that.
And
But you should be comfortable with the 3 basics.
we probably went over this when we went over all of this to reverse, right? How can a like a point like where the extreme of the f of prime doesn't exist? Does that make sense? Like how can you have a non-existent point?
If there's a hole there, if there's like.
So we're checking for where f prime does not exist. So let's say
Oh,
you could have an issue of what would be, let's say, a vertical tangent line. Because the slope of that tangent line would be undefined. That's an example. Okay, so let's go ahead and do this one. So k, we look at the derivative. So k prime of x would be equal to e to the negative x squared times the derivative of the exponent, which is negative 2x.
you'd also multiply by the natural log of b, right? But that's just one escape included.
So remember that the derivative of e to u is equal to e to u times du dx.
We don't multiply by the natural log of the base. Well, yeah, but just in general. So if we had like 2x to be the
If you forget this formula, you could go about taking the natural log of both sides, call us y, and you have the log of y is equal to natural log. So natural log of y equals natural log of this, which allows you to bring the exponent to the front, and that becomes ln e from 1. But then you have to deal with implicit differentiation, and you have to know the derivative log. If you had to do that, yeah, you could do that. You had to. If you can't remember this, it may be easier just to remember that. Okay, derivative with respect to x of e to the u, which is e to the u times du dx.
So this one doesn't include like natural logs at all. Like the shortcut doesn't include natural logs at all. You don't multiply by the natural log of the base.
Yeah. So what is the ln of e?
It's 1.
Yeah,
right?
exactly.
So, but that's not included in this. So like if we had natural log, if we had 2 e to the, does that mean so if we had 2 e to the negative?
Yeah. So this is absolutely correct. Where u is any sort of differentiable function of x.
Okay, and if we had a 2 in front of the e, would we find the natural log of 2? I'm just, never mind. I think I got it.
What are you doing? Wait, actually, I got a shot.
If you had a 2 in front of the e, let's say you had 2.
E to the negative 2x. You know, if we just put a 2 in front of that function.
Okay. So if you had that situation, you could technically apply product rule. You're gonna find that the 2 would go to 0, then blah blah blah, plus leave the 2 alone, and the derivative of this, which is this.
Okay. Thanks.
Mhm.
Makes a lot of sense.
Yeah, 'cause if there's a problem like that, it's not your actual
All right, so where does this function not exist? Or where does this function equal 0? Because there's no issue of it not existing.
Let's set it equal to 0
So,
and figure it out.
when you have a negative exponent, what you want to do is go ahead and do this. So if you do this, you can, it makes it more clear to see where you have issues of division by 0. Okay. So is there any value of x that would give us where f or k prime of x does not exist? I mean, can we in any way have division by 0? No. So taking care of that guy. This guy's been taken care of. Is there any value of x where we could have k prime of x equals 0, which is the second point to look at?
Yes.
Yeah.
When x is 0, right? Because imagine if x were 0, you'd have 0 divided by 1, which is 0. So good. So k prime of 0 would give you 0 over 1, which is equal to 0. So 0, 0.
Now, would we not plug that 0 back
So
into
sorry.
the original equation?
So this made this equal to 0, right? So to know the value of this local extrema, you would need to plug it back into the original equation, yes. So be careful there, right? The value of the function is the original function, right? We did this just to see where f prime of x equals 0, so we know, oh, okay, we can see that it occurs at x equals 0. So what is k of 0?
0, 1.
So we say k of 0 is equal to e to the 0, which is equal to 1. So this is one of your local extreme values. And so far that's the only one we found. So far so we got 1 because k of 0 is e to the 0, which is 1, right? We found out where k prime equals 0, so then, okay, where that is, well, what is that value? Well, that's the function itself, the original function, that is its value. Okay, so we've taken care of, and is that the only place where k prime of x can be equal to 0? And the answer is yes. And that's the only value that would make the numerator 0 without making the denominator 0, but we found out that wasn't even possible. So that's taken care of. And now the last thing to check are endpoints. So this guy is over all real values of x. So this is where you would have to be comfortable with knowing what this guy looks like. So let's say you didn't have a graphing calculator. There's nothing wrong with plotting points. Right? There's nothing wrong with plotting points, and then once you see, oh, okay, I see what's going on. Okay, I see. So if we had to graph this, let's say you didn't have a graphing calculator, let's go ahead and do it. So k of x is equal to e to the negative x squared. I will probably not give you one like this on the quiz, just because it is time consuming, but you should know how to do this, so let's see that we go over this. I will try to move as quickly as I can. Sometimes fast, sometimes not. Alright, so if we plot some points here. So first off, whenever you graph a function, let the asymptotes, horizontal, vertical, let them be the skeleton of your graph. So, okay, so are there any issues where we have vertical asymptotes? No, right? There's no way for that to have division by 0, right? Right, it's not possible. So there's no vertical asymptote, okay? So then you have to look at in behavior. Really? Because that's all we really care about for this. We could graph this whole thing, but let's not forget that all we're interested in finding are the local, extreme, or absolute. You know, if you find local, some of them may be absolute depending on where they are in the interval and all that. So we're finding extreme values, okay? We don't even know what the whole thing looks like, right? Not really. But the in behavior is probably the most important. But let's just go ahead and see what this thing looks like. So and we can just make up some values, right? There's nothing wrong with doing that. Let's make up some values. When x is 0, what do we have? 1 over 1, right? Which is 1. Let's see, 1 over e. E is approximately 2 and change. Anyone have a calculator that has e? Help us out.
I should probably grab you my calculator before the test.
I should probably charge my graphic calculator. It's been definitely out here lately.
So when x is 1, we have 1 divided by e. Yes, exactly. So you already see what's going on here. So when you have 1, you have 0.3, whatever. As x gets larger, does the function just go down? Right? Right. It gets as x gets larger and larger. This denominator gets larger and larger. So there is a horizontal asymptote. Uh-huh. Right. Right, so think about horizontal asymptotes, they derive from in behavior. They come from in behavior. So as x gets really, really large, the denominator gets really, really large. What happens when the numerator remains fixed, but the denominator gets larger and larger and larger, you are approaching 0. Same for as x approaches negative infinity, right? Because when you take a negative value and square it, it's always positive, so it's going to have the same, it's going to pretty much look the same going this way. So now can we answer? Can we answer the question? Are there any local or absolute extrema?
There's an absolute upon 0.
Yes, there's an absolute.
Definitely an absolute max right there.
But there's not an absolute.
At x equals 0, and the value of it is 1. Absolute max value of 1 at x equals 0.
And then because our intervals are infinity to negative infinity, we would not have ones that had points.
Exactly. There's no endpoints to check. So this definitely is absolute max, and that's it.
Cool. That's not that bad.
If you don't mind, I'll borrow it till the end of class in case I need to use it again. Thank you. Okay, that's that. So moving on. The bell's about to ring.
Yeah, we've been in it like 2 minutes.
I thought it was 45.
Wait, Becca. Wait, Becca.
Oh wait.
Hang on a second.
I still live.